Welcome back to part 2 of Monday, April 20th. We're going to continue on with our special cases. So we just went over difference of two squares. Now we're going to talk about something called a perfect square trinomial. So for your warm-up, part 2, go ahead and factor x squared minus 8x plus 16 and 4x squared plus 12x plus 9. This one is a trinomial with a leading coefficient of 1, meaning you can just use normal p's and q's. This one has a leading coefficient of 4, meaning that you're going to need to use something like slip and slide or supergrouping or double cross or something like that, okay? So go ahead, pause the video now to give these a try on your own. And then just like we did with our first special case, difference of two squares, there is a shortcut here that you might be interested in. All right, number 1, trinomial, 3 terms. No leading coefficient means we can use p's and q's. So here we're going to use p's and q's. So set up my answer. I know my answer is going to be a product of two binomials. I know my first term is going to be x because x times x is how I get x squared. Now we play the p's and q's game. What two numbers have a sum of -8 and a product of 16? So what, where can I put this? Put it over here, put it right here, put it over here. What times what is 16? That when I add them together, I get -8. Whoops, -8. Yeah, -8. I'm thinking. Well, 4 times 4 is 16, and 4 plus 4 is +8. So how do I get -8? What if I made it to -4 and -4? Does -4 times -4 equal 16? Yes. Does -4 plus -4 equal -8? Yes. So my answer is -4 and -4. There's something interesting about that, isn't there? They're the same exact binomial. Did you do that? X minus 4 and x minus 4, it's the same binomial. Do you know what happens when you have the same binomial like that? What you can do is you can actually write your answer like this. What? I know, totally crazy, right? Because a square basically means multiply something by itself. Just like I could say 9 times 9 is the same thing as 9 squared, or x times x is the same thing as x squared. If I have x minus 4 times x minus 4, I can write that as x minus 4 squared. I know, cool, right? It's good to know that because I'm pretty sure on your IXL practice, and definitely in your worksheet practice with your answer key, it's going to be written as called a perfect square. So keep that in mind. All right, that was kind of cool. Let's see what happens over here. So for this one, leading coefficient of 4. Well, let's see if we can do a GCF, because sometimes GCF factoring gets that leading coefficient out of there. Does 4 go into 12? Yes. Does 4 go into 9? No. So we can't do GCF factoring. Bummer. So that means we have to use slip and slide or supergrouping or double cross. Because of the amount of space I gave myself, I'm going to do slip and slide just because it requires the least amount of space. But if you did something else like supergrouping or double cross, you should still end up with the same answer. So slip and slide, I'm going to take the leading coefficient and I'm going to slip it on down. 4 times 9 is 36. Now, because I'm working in like this alternate universe, I put quotations around my new trinomial because it's not actually the same trinomial, something totally different. I'm just using it to figure out the answer. So my trinomial became x squared plus 12x plus 36, which then I go ahead and I play the p's and q's game. Now to keep this video a little bit shorter, I'm just going to jump straight to doing the p's and q's game in my head and putting it into an actual answer. What two numbers have a product of 36 and a sum of 12? 9 times 4 is 36, 9 plus 4 is 13, so I'm close. What about 6 and 6? Yeah, 6 times 6 is 36, 6 plus 6 is 12. So I'm still in my alternate universe. My answers are +6 and +6. Again, I did that more in my head because we've done a lot of p's and q's factoring up until this point. Now notice that's not my answer. I'm still working in that alternate universe. I need to bring this back to the same universe. I did my slip. Now I do my slide. I take my 4 and I slide it underneath here. Slide it underneath here. All right, 6 divided by 4 and 6 divided by 4. Now, I can't divide 6 by 4, but there's something interesting about these particular fractions. 6/4 is a fraction that can be simplified. So before you bring it out of its alternate universe, this is kind of a cool problem. You first want to simplify these fractions. So keep it in that universe and make it 6 and 4. If I factor 2 out, that'd be 3 halves. 3 halves. So this would be x plus 3 halves. So in this case, we haven't had to deal with something like this before, but you have to simplify the fraction before you can continue the slide. So I've basically simplified 6/4 to 3 halves, but 3 halves can't be simplified past that. So what do? I basically am multiplying both terms by the denominator. I'm multiplying both of them by 2. Or in other words, I'm sliding 2 in front of the x. So my final answer is 2x plus 3 times 2x plus 3. Wait a minute. Something similar over here that it was over there? I think so. It's the same binomial. It's 2x plus 3 times 2x plus 3. So guess what? You can write that as 2x plus 3 squared. Yeah, crazy, right? Totally crazy. So what's special about both of these examples? They're what we call perfect square trinomials. And the reason why we call them perfect square trinomials is because when you factor them, your answer is a perfect square. So now I'm going to show you a shortcut because that is a lot of work and I don't really want to do that much work every single time. So just like we did with difference of 2 squares, I'm going to show you a little shortcut that you can use with these perfect square trinomials. Okay, grab your notes. Here we go. So I'm going to be honest with you. These ones are definitely a little bit weirder than the special cases of the difference of 2 squares. And by the way, this is an optional shortcut. We were able to factor 2 perfect square trinomials using methods that we already have. So if you don't like using these shortcuts, you can always use the long way. It's totally fine. But guess what? When you get to Algebra 2 and beyond, you're going to want to know these shortcuts. So I'm going to expose it to you now. And then if you don't like it, you don't have to use it. That's the beauty of this. So these are called perfect square trinomials. We're going to look at why they're called that and how to use this shortcut and when it can be used. So the first thing that stands out to me is trinomial. Trinomial means it must have 3 terms. So that's checklist item number 1. Does this have 3 terms? Yes, it does. Now notice it's called a perfect square trinomial. Just like difference of 2 squares, a perfect square trinomial, the first term and the last term must be perfect squares. In other words, is x squared a perfect square? Yes. Is 9 a perfect square? Yes. Now here's the thing though. There's a middle term here. When we were doing difference of 2 squares, there wasn't a middle term. In fact, you can kind of see that math, that review math that we did before. The middle term was 0, which is why your answer contained a positive and a negative. But here the middle term is -6. So here's the thing. It's a little bit weird, but bear with me. There's actually a third checkpoint. So check 1, does it have 3 terms? Yes. Check 2, is the first and the last term, are they both perfect squares? Yes. Check 3, you want to look at the middle term. So I'm going to write this out for you. The middle term has to be the sum of the square roots of the first and the last term. So let me show you what I mean by that. You start by taking the square root of the first term. What's the square root of x squared? X. Okay. Then you take the square root of the last term. What's the square root of 9? 3. Now, the middle term has to be the sum of basically, or excuse me, I said sum, that's wrong. It has to be the sum of the last term multiplied by the first term. So let's do it like this. What is 3 times x? 3x, right? Well, what's 3x plus 3x? 6x. Is the middle term positive 6x? Ooh, close. It's negative 6x, right? So how can I, what can I, oh, wait a minute. Hold on. There's something I could do here. there's a different way to write 9, or the square root of 9 can also be written as -3. So let's try this again. What's -3 times x? -3 times x is -3x. So if I were to multiply these, you get -3x. What's -3x plus -3x? -6x. Is that the middle term? Yes, it is. Okay, so if that totally confused you, don't worry. We'll go over more examples. So again, step 1, does it have 3 terms? Yes. Is the first term and the last term, are they both perfect squares? Yes. When you multiply the square root and add them together, do you get the middle term? If so, here's how simple this becomes. And again, remember, you don't have to factor this way. It's as simple as this. Just like we did with our difference of 2 squares, you set up your 2 binomials. The first binomial is the square root of the first term, x. X and x, excuse me. The second term is the square root of the second term, 3 and 3. But as we noticed, it wasn't actually positive 3 here because our sum had to be -6x. It was a -3. So we wrote this as -3 and -3. Well, what did we learn in our warm-up that we can do when we have the same exact binomial multiplied by itself? You can write that as x minus 3 squared. That's all you have to do. Now, for some of you, this is going to be way too confusing. And guess what? With something like this, if you don't want to use this shortcut, you don't have to. You can just do P's and Q's. What 2 numbers have a sum of -6 and a product of 9? Oh, guess what? -3 and -3. That's all that you have to do. So if you don't like doing this, you can always do what we did in our warm-up. You can always use your regular methods. I'm just showing you a shortcut because, as you'll see in the second example, it gets a little bit more complicated and you might want a shortcut in that sense. So here we go. Let's look at the second example and then we'll wrap things up with an extra ticket. Example number 2. This one is messy. So 9m squared. I feel like it's about to fall over. 9m squared minus 30m plus 25. Whoa. Okay, now remember, if you wanted to, you could do something like slip and slide or super grouping or double cross with something like this. Can't do P's and Q's though, because it has that leading coefficient. But doing 9 times 25, 225, and then trying to work your way back to get a sum of -30, no thank you. That sounds like a lot of work to me. This looks like something that most of you would try to either look up an answer online or you would just say, no, thank you, and move on. So this is the type of example where knowing how to do perfect square trinomial factoring actually helps. So let's go through our 3 checkpoints. Number 1, is it a trinomial? 1, 2, 3, yes. Number 2, is the first term a perfect square and is the last term a perfect square? Yes and yes. Number 3, this is the weird one. Is the middle term the sum of the product of the first and the last term? So that's the part that we got to figure out. We don't know that yet. So here we go. Let's take the square root of the first term. What's the square root of 9m squared? What times what is 9m squared? That would be 3m, right? And what's the square root of positive 25? That would be 5. So what we're doing here is we're going to multiply the first and the last term together, 3m by 5. What is 3m times 5 is 15m, right? Okay, so we found the square root of the first, the square root of the last, and we multiplied them together. Is the middle term the sum of 15m and 15m? In other words, does 15m plus 15m give us -30m? Ooh, so close. It gives us positive 30m. Wait a minute. What's another way to get positive 25? What if I was -5 times -5? Yeah, that would work. So 3m times -5 is -15m. Negative 15 plus negative 15 is negative 30. So is this a perfect square trinomial? Yes. How do we know? It has 3 terms. The first and the last term are perfect squares, and the middle term is the sum of the product and the last term by itself. So instead of doing like supergrouping and double cross and all of that stuff, we get to jump straight to the answer. Product of 2 binomials. First term is the square root of the first term. The square root of 9m squared was 3m. The square root of 25 is 5. But how did we end up getting a negative 30m here instead of a positive 30m? We made it a negative 5. Now remember, when it's the exact same thing, 3m minus 5 times 3m minus 5, we can write this as 3m minus 5 squared. Now, could you have come to that answer using a different method? Absolutely, but it would have taken a whole lot more work and a whole lot more steps. So this is called a perfect square trinomial. We're going to wrap everything up with an exit ticket, going over 2 more examples, and then you can work on some worksheet practice. Alrighty, let's wrap things up with our exit ticket looking at perfect square trinomials. Your first exit ticket is 4x squared plus 20x plus 25. Your second exit ticket, 25m squared minus 10m plus 1. Go ahead and pause the video now if you want to try them on your own. And here we go. So again, it's in the name. Is it a perfect square trinomial? Meaning, does it have 3 terms? 1, 2, 3, 1, 2, 3. Yes. Is the first term and the last term, are they both perfect squares? Is 4x squared a perfect square? Yeah. 25 a perfect square? Yeah. 25m squared a perfect square? Yeah. 1 a perfect square? Yes. And the third item, which is not in the name, and this is where things get weird, which again, by the way, you don't have to do this. This is totally optional. You could always do slip and slide, double cross, or super grouping if you wanted to. Here we go. You have to check the third criteria. The third criteria is that middle term the sum of the first and the last multiplied together and then added? So here we go. To figure that out, let me use a little bit different pen. We take the square root of the first and the last term. What's the square root of 4x squared? 2x. Okay, and then we take the square root of the last term. What's the square root of 25? 5. We multiply these together and then we add them. So what is 2x times 5? 2x times 5 is 10x. Does 10x plus 10x equal positive 20x? Oh, in this case it did. Because they add up to a positive, we know that they're both going to be positive. So is this a perfect square trinomial? Yeah, it is. Because the square root of the first term times the square root of the last term has a sum of the middle term. All right, well in that case, we know what to do now. All we do is set up our final answer. Binomial times a binomial. So what was the square root of the first term? The square root of the first term was 2x. So we know the first term in our answer is going to be 2x. 2x times 2x equals 4x. What was the square root of the last term? The square root of the last term was 5. 5 times 5 is 25. And did we make it positive? Were both of these positive or were both of them negative? Well, if you look, both of them were indeed positive. So this is 2x plus 5 and 2x plus 5, which we can write as 2x plus 5 squared. Did you have to do it that way? No, you can do this any way that you want. Double crossing or double cross, super grouping, flip and slide. Don't have to do it this way, but it does save a whole lot of space, doesn't it? All right, let's look at the last one. It is a trinomial. Both of these are perfect squares. Let's check the middle term. You can't really check the middle term by looking at it. You got to do some work. All right, take the first square root of the first term. What's the square root of 25m squared? That would be 5m. Okay. What's the square root of 1? Don't forget, 1 is a perfect square. The square root of 1 is 1. So let's multiply these together. What's 5m times 1? That would be 5m. Does 5m times 5m give us negative 10m? Uh-oh. close. 5m plus 5m would give us positive 10m. So how do we make it negative? Well, you just make them both negative 5m. So that means this is actually a -1, not a positive 1. Because -1 times -1 is still positive 1. So does that work? Yeah, -5 plus -5 is -10. So is this a perfect square trinomial? You betcha. So let's go ahead and put it as a product of two binomials. What was the square root of the first term? 5m. So 5m and 5m. What was the square root of the last term? 1. But oh wait, remember, we couldn't keep it as positive 1 because if it was positive, then the middle term would have had to be positive 10m. So when we changed it to a -1. So this is -1 and -1, which can be written as 5m minus 1 squared. All right. That wraps up our special cases, perfect square trinomials. Go ahead and check out the worksheet practice with attached answer key, and we will continue more of these practices in our next video. Have a great day and have fun factoring.